Hey everybody, Randy Writings with 101 Great Ideas. Today I'm going to be talking about a do-it-yourself one-day build folding plastic kayak that my daughter and I put together a couple years ago. We did it as a school project kind of thing, just a one day, let's see what we can do. Now the preparation took more than one day, but the build only took one day. It was very, very inexpensive. This idea started at first when I saw some challenges on YouTube to make a boat out of a single 4x8 sheet of Coroplast or corrugated plastic. That's this stuff here. It's what you see a lot of yard signs, political signs made out of. Usually comes in a 4x8 foot sheet, and people take them and they fold them and cut them and try to make, you know, a boat out of a single sheet that a person can float it. I went to my local plastics place to get a sheet. I thought this would be kind of fun to try, but then the idea changed a little bit. A sheet of Coroplast normally costs about $25 to $30, but my local supplier had a bunch of scrap pieces all the same size. They were the same 4-foot width, but only 20 inches across. My local company had a whole bunch of these, so I ended up buying like 100 of them because I got them really, really cheap. And I've now used these to build all kinds of things. One of the things I built was this pontoon. Well, two of them actually. This is one side that goes on my amphibious craft. That's been a little beat up now, but this lasted for about 2 years, has a couple thousand miles on it, hanging on the boat, and a few hundred miles in the water, used as a stabilization pontoon. But it held up very nicely. There's more on that that'll be on the playlist for my amphibious vehicle, the quad deck. I started with a sheet like this, but then what do you do with it? Or a whole lot of sheets like this, actually. I came up with the idea of making a scale model. So these are backing boards for comic books or magazines. You can get them in almost any comic book store, buy a whole bunch of them. They're pretty nice cardboard. And I thought this scaled pretty well for the Coroplast. Then I did some measurements and I cut pieces this size. These are 1 to 12 ratio for the sheets of Coroplast. So 4 inches across and then a 1/12 of 20 inches wide. So the dimensions of this are the same as the dimensions of my Coroplast. So then I could just take these and start cutting them and folding them. And this cardboard has enough thickness to it that it folding mimics, you know, how much you could fold a sheet of Coroplast before you wouldn't want to fold it anymore. Now, back to the Coroplast a little bit. It comes in different colors and thicknesses and grades. It has channels. It's made almost exactly like corrugated cardboard. So it's got 2 outer sheets of plastic and then corrugations. So a single piece of it is actually quite strong. If you want to make it really strong, double it up, that's what this is, and turn the grain 90 degrees. So this side, this grain goes this way, but this side, it goes this way. So I cut these different and put them together, and this is just unbelievably strong. I mean, I would have to bend that over my knee probably to break it. I might be able to do it with my hands, but, and this is a paddle also for my amphibious vehicle that lasted for thousands of miles. These things that hit curbs, that hit rocks in the water, all kinds of stuff, and they would bust a bicycle spoke before the paddle would break. I broke 3 spokes. I never broke a paddle. I took 3 spare paddles with me. At the end of all my travels, I still had 3 spare paddles. That's how strong this stuff can be. So I took my model pieces, my individual sheets that represented one sheet of the Coroplast that I had, and I started cutting and folding and doing things, and I came up with a couple of models. I'm going to show you two models today, but I'm going to show you one boat because the other boat's too big really to fit in the frame in this studio. But this is the model that I made for my daughter's boat. That's the one we're really going to concentrate on today. This looks like a lot of sheets of cardboard, which would correspond to a lot of sheets of Coroplast, but it's really not. In effect, it's 4 triangles, and the triangles are made by taking one sheet, cutting it diagonally, flipping the 2 triangles where they mirror each other, and that makes one side. There's 2 sides on the bottom, 2 sides on the top, which means you have 4 sheets of Coroplast make this entire boat. Now you may notice that that didn't line up when I did that, and that's because this was a model that I made before I figured out that I wanted models made on a 1:12 or 1 inch to 1 foot ratio, which just makes measuring a lot easier. So I made this, I just cut some pieces out, kind of guessed, and then I realized I couldn't do that if I wanted to take pretty precise measurements off of it, or fairly precise. So I went back. Now, the real model for my daughter's boat got lost in the abyss that we call her room. It's in there somewhere, but I wanted to show you that one. Now, okay, here we have the 8-inch model of a Coroplast boat. This is made out of cardboard and tape. We are preparing to make a full-size boat here. 4 sheets of Coroplast, couple rolls of Gorilla Tape. This boat is for Johnny, my daughter. I'll show you the other model. This is the right dimensions for this. And if you see, you can tell that that piece right there is just one of those cut in half. These are whole pieces with a little trimmed out. So this boat is a 12-foot boat. It's mine. It took me a while both to figure out the design I wanted and the order that you need to tape things together. That's pretty crucial. You can't just start taping stuff together because you do want to get tape over the seams all the way in the inside on both sides. So at some point there's a photo that shows kind of what I call the fans that we made. So I made these 2 pieces and these 2 pieces and taped them together in a fan, and likewise on the bottom, then did an inside seam in the middle, and then just kept going over and over. I didn't want to get the seams too thick, so I kind of counted. I'd have 2 on the inside and 3 on the outside and overlap them so they locked together. A lot of times I did a single piece of tape down a seam and then went over each side of it to hold it down. There's those kind of decisions that I had to make. So I did all that and just kind of figured out how we were going to do it. In the end, her boat ended up costing $20 to make. And because I got the Coroplast so cheap, that's $2 of Coroplast and $18 of Gorilla Tape. I'm going to grab her boat now, move some stuff out of the way, and set it up for you and show it to you. This is her boat. Like I said, it folds up. I figure you can put about 20 of these in the trunk of a car. I wouldn't really count this as being a seagoing vessel. I wouldn't take it down any kind of rapids. But as you'll see in some photos, it did float. This is now a couple years old. There's almost no wear to it. I mean, we've had it kind of in storage, but it still folds up. The tape is still holding on. I mean, there might be a few places that I would want to just re-stick the tape a little bit before I launch in the water, but all in all, it really looks pretty good still. Unfolded, this is an 8-foot boat. It's 4 feet right now. You can see the width, it's about 3 feet across. It might be a little shallower than I would like, and there's a couple other small problems, but for the most part, it came out very well. Let me unfold it now, and I'll show you what it looks like set up. So this is it, still flat. But what's in here are the braces. I came up with this kind of a bat wing idea. Probably going to speed through this part while I do this. Here it is, set up to actually go in the water. The braces go behind the rower and then up, kind of act as foot pegs as well. One of the problems we had was, and I knew going in it was going to be a problem. When she got in really good, settled down, and then reached down to kind of settle herself and collapsed one side, took on a little bit of water. Got the side back up real quick, and really it wasn't any problem. In the future, what I think I would probably do is take some Coroplast and just fold up a couple of triangles, like shipping tubes, those triangle shipping tube shapes that would go here and here. The other thing I could do with this, if we didn't want to fold it up, is I could do foam like I've done in my pontoons for things. Just foam the front, pull it out where it's got a good shape to it, and then foam the front and back, and then pour foam in the sides and just leave it that way. It'd be good enough to, play around in a pool or a pond or something like that. I had to put gaps here. The plastic reaches from about there to there with tape in between, and that's so the whole thing can fold up. So if you're going to put one of these together, you have to very carefully figure out where the tape needs to hold the pieces directly together and where you might need a little bit of a gap so you can have folds. That's where doing the model was a good idea, because when I did the model and I just taped straight over things and I went to try to fold it together and it wouldn't fold over, that taught me that I needed to give it a little bit of a gap there so it would fold. One of the other things that I might have changed is it's got kind of a surf ski nose to it, where the nose is flat this way, where most kayaks go into the water with a bow. And if I was going to redo this, I might try to do that where it had more of a bow shape to it. The other thing you could do is, along with the bracing there, is maybe put a sheet or two underneath to just give a better place to sit. So I'm going to end this with some photos of the original build, and we got to launch it in a pool the day we built it. So we started in the morning. I had the model already done. I had just a stack of the sheets of Coroplast. I hadn't cut them or anything. Had a bunch of rolls of tape, and together we did the measuring and the cutting and the taping, put it all together, folded it up. Okay, and here we are, complete. Worked out about 8 feet long. It's got about a 10-inch draft. I think it'll probably have about a 3 or 4 inch water line. Finally designed some decent inserts back here and in the front. Took it to the Y, asked them if we could put it in the pool. We hadn't asked ahead of time, and they were nice enough. They let us. They said, you got 5 minutes, go in, set it up. And then we had a bit of a crowd, but it worked out really well. She got in it, it floated, she paddled around a couple of circles, came out, and that's about all we've done with it. It was just kind of as a proof of concept to see if it would work, and it did. All right, little water test. We got to figure out how to brace the sides a little bit. It's not bad. Folded it back up. that's how easy that folds up. Braces are right there. If I ever make the support braces, I will make them where they will unroll and tuck in there as well. So this is what goes with you. Put in the back seat of a car and take it. Obviously you need a paddle. I think this is a great one-day build to do with the kid. We had a lot of fun. She learned a lot. We talked about water displacement. We talked about building a model so you can visualize what you're doing and measure. We talked about figuring out the order that you had to do things, the taping and leaving gaps so that it would fold, all those pre-planning kind of things. You can't just push your way through it. You got to think your way through it first. So lots of cool lessons, lots of fun. At the end of the day, she was sitting in a boat floating. Well, thank you all for stopping by my channel. I'm Randy Ridings with 101 Great Ideas. And remember, scrappy, litigious chihuahuas.